Standard 8111, we're going to classify real numbers. We need to know the difference between rational and irrational numbers. Rational numbers are any number that can be written as a fraction. They are fractions, whole numbers, integers. So here's some examples. All of these examples are rational numbers. As mentioned, rational number, it is a fraction. So as a decimal, this fraction terminates or stops 0.5, 1/2 is 0.5. This fraction, all fractions are rational numbers. As a decimal, this fraction repeats, so 0.3 repeating. 3 is an integer. We can make that a fraction as 3 over 1. The next one is square root 4. The square root of 4 is 2, and we can make that a fraction, so that would be 1. So basically, any number that inside that square root there, if it's a perfect square, it will be a rational number. Irrational numbers are numbers that can't be written as a fraction. Here would be a few examples of irrational numbers. Pi. Pi is a number, can't be written as a fraction. Why? Because the decimal goes on forever and never repeats. Same thing with square root 2. Square root 2 is not a perfect square. When you put the square root of 2 in your calculator, you get 1.41421, and it just keeps going on forever. It never repeats, it never terminates, so it is an irrational number. Some other things that you just need to remember here is that any time you have a rational plus a rational, you will have a rational outcome. So the sum of a rational plus a rational is rational. Rational plus irrational, this is going to be an irrational outcome. Products, when you're talking product is multiplication. A rational times a rational will be rational. A rational times an irrational is irrational. However, there is one exception, is when you have the irrational number, or the rational number of 0, 0 times irrational is going to give you a rational outcome. That is the only time that will happen when you take a rational times an irrational. Cover a few examples. Example 1, the number 0.4 repeating is a repeating decimal. Is it rational or an irrational number? Well, you should state that it is a rational number because every repeating decimal can be written as a fraction. Explain your answer. Well, you simply explain repeating decimals can be written as a fraction. So every repeating decimal can be written as a fraction. Example 2, Jerry is grouping a set of numbers into rational and irrational numbers. Which of the following numbers would Jerry place into the set of rational numbers? Of irrational numbers. Well, square root 9 is going to be rational. Okay, that is 3. Negative 1/2, B and C, those are both fractions. If they're both fractions, they're both rational numbers. So the first 3, none of them would be irrational. So that leaves us square root 20. Square root 20 is not a perfect square. It is irrational. So here our answer in 2 would be D. 3, which of the following are irrational numbers? Which of the following are, meaning plural, more than one? 0 is a rational number. So it is an integer, it is a rational number. Example 2, 0.666. Notice the 6 repeats. It's a repeating decimal. Repeating decimals are rational numbers. Cube root 9 is not a rational number. Cube root is basically saying what number times that same number times that same number is going to give you 9. The closest thing that you could get is 2 times 2 times 2, which is going to give you 8. It's not going to give us 9 here. So if we tried 3, 3 wouldn't work. It would be too high. So the cube root is irrational. You can't have a rational times a rational and get an irrational to get 9. So therefore, this is irrational. And then the square root of 2 is also not a perfect square, so that is irrational. So 3 and 4 are both irrational numbers, and our only answer here would be answer D.